Hello, my name is Britta, and I would like to let you know how artificial intelligence reduces downtime of critical machineries and improves maintenance processes in various industries to a high extent. Often machinery is maintained based on predefined cycles or when sensor limits are passed. However, condition monitoring has often led to maintenance activities, although machinery would have operated well for a longer period. Or the other way around, despite these maintenance activities, critical machineries failed. The reason for this is the purely past-oriented analysis. Focus is laid on what has happened, instead of why did it happen and predict what will happen. Especially root cause discovery and recommendations for machine operators to avoid machine failure in the future are critical knowledge. New artificial intelligence analytics enables validated understanding of the future. Self-learning algorithms inject predictive intelligence into relevant components. In this way, thanks to predictive and demand-oriented maintenance, you save time and money. Both machinery operators and machinery producers benefit from next-generation maintenance. New business models are created to offer value-add services for predictive maintenance analytics, for example via cloud. Due to the fact that complex processes are changing again and again and are influenced by dynamic disturbing factors, it is necessary to have reliable failure predictions despite those significant process changes. Self-learning predictive intelligence adjusts algorithms automatically. In this way, changed machinery behavior is discovered reliably, and algorithms are also automatically adapted to individual machinery instances. If a data scientist has to adjust calculation logic again and again, then this would be very time-consuming and expensive. Even complex processes can now be analyzed with dynamic pattern discovery. Optimize your production and maintenance activities in an innovative and future-driven way. Let's have a look at some references. At German rail cargo, total damage of locomotive motors can be avoided by predictive maintenance. Preventive actions reduce costs to less than 10% of normal motor damage, which sums up to around €200,000. For Siemens, prediction accuracy is realized higher than 99% for predictive maintenance in complex automotive industry. At Daimler, welding robots were analyzed for predictive maintenance. And for entity facilities belonging to the Japanese entity group with €90 billion revenue, failure prediction was done for critical air conditioning systems which, for example, cool down IT data centers. Just imagine, servers would overheat and data would be lost. In this project, results of 98% accuracy were realized in failure prediction for air conditioning system compressors. All companies, whether a production company like Siemens or a logistics provider like German rail cargo, have one thing in common. They can get value add out of their data in order to control relevant processes in a predictive way. In this way, inefficiencies are avoided before they actually happen. I hope these short project examples into the world of predictive intelligence have proven that self-learning artificial intelligence has realized value add in maintenance processes for production and logistics. It's not utopia, it has reached reality. If you want to know how you can improve your maintenance sustainably by artificial intelligence, I would be pleased to let you know. I'm looking forward to talking to you.